I'm really delighted to be giving a keynote at CogSci, and I'm grateful to all of the organisers, especially Anna Drummy and Mike Mack, who have done some hand-holding as I've been preparing for this, my very first virtual presentation. Now, I want to talk about something which is actually quite close to the central theme of this conference, about the way that human minds are transformed in the course of childhood development. They're transformed, I think, through social interaction, and they are changed much more between birth and maturity than the minds of non-human animals. But I think the engines of that change, in addition to social interaction, are cognitive mechanisms that we have in common with a wide range of other animals. So in other words, I want to talk about what I call cognitive gadgets, about how in the course of development, we get new kinds of thinking from old parts. This is Perseverance. It's the latest Mars rover that's going to investigate past microbial life on the red planet, and it's going to work out how future astronauts can survive on the planet by converting carbon dioxide into oxygen. Now, this is the kind of high-tech, high-concept project that reminds us how different human lives are from those of other animals. And it pumps the intuition that our minds are completely different, that our minds are bristling with shiny new cognitive kit supplied by genetic evolution. But as a comparative psychologist who turned into a cognitive neuroscientist, who turned into a theoretical psychologist, yes, I've been a bit restless, I am resistant to this intuition that human minds are all new. Instead, I think that the vast majority of our cognitive processes are nothing to write home about. They are based on the same computations as cognitive mechanisms found in other mammals, and in some cases in an even wider range of animals, right, extending to invertebrates. Now, in some cases, our attentional, learning, memory, decision, and motor control processes have expanded relative to other primates, perhaps to earlier hominids. They have quantitatively changed such that they can handle more information and they can process it faster, but they are qualitatively similar to what's found in other animals. Distinctively human cognitive mechanisms, mechanisms which are found only in humans, absent in other animals, or present there only in some kind of trace form. I think there are very few of those, and that they are, as it were, the icing on the iceberg. And they are what I call cognitive gadgets, distinctively human cognitive mechanisms. So what are these distinctively human cognitive mechanisms? Well, here are the front runners, the best candidates. Obviously, it includes language and mathematical cognition, but there are a number of others, including imitation, our capacity to copy the fine details of body movements. Mind reading, also known as theory of mind, our capacity to ascribe thoughts and feelings to ourselves and to others, and to predict and explain behavior that way. Mental time travel, our capacity to think about specific episodes in the past and to project ourselves forward into the future for planning. Mental mapping, we can represent space and objects in a kind of an aerial view in Cartesian coordinates. Causal cognition, we can think about the movements of objects, including dominoes, as being due to hidden causes governed by general principles. Selective social learning, we can decide strategically who to trust when we're learning from others. Moral reasoning, we have concepts of right and wrong, of what we should or ought to do. And metacognition, we are able in an explicit way to represent, regulate, and control our own cognitive processes. Now, I've looked in some depth at a number of these distinctively human cognitive mechanisms. My hunch is that they are all what I call cognitive gadgets. But I'm going to talk today about just two of them, imitation and metacognition. So the rest of the talk comes in two chunks. First, I want to say more about what I mean by cognitive gadgets, and first to do that in the abstract, and then to make it much more concrete by focusing on the example of imitation. Then I want to ask, what are the implications of the gadget view for cognitive science? If the cognitive gadget theory is right, then what should cognitive scientists who are interested in origins, the development and evolution of cognition, what should they bear in mind, and what kinds of questions should they ask? And again, I want to do that first briefly in the abstract, and then to focus on the example of metacognition to make it more concrete. So, cognitive gadgets. Well, a little bit of history. In the early 1990s, the evolutionary psychologists, Leda Cosmides, John Tooby, Steven Pinker, founded evolutionary psychology, saying that distinctively human cognitive mechanisms are cognitive instincts. That is, that they evolved in the Stone Age era to meet the demands of life at that time, and they evolved through evolution acting on genetic variants, straightforward natural selection, and that now each of us inherits a program for the development of each distinctively human cognitive mechanism, a program which unfolds in the course of childhood. Experience is certainly needed for that unfolding, but the experience plays a triggering or a tuning role rather than a constructive role. Now, my theory is a contrast with standard evolutionary psychology. So I chose a contrasting term, cognitive gadgets. My suggestion is that distinctively human cognitive mechanisms are able to do their jobs because they have been shaped not by genetic selection, but by cultural selection. So socially inherited variants, rather than genetically inherited variants, sometimes show slight improvement, the cultural equivalent of mutation, and those improvements proliferate to the extent that individuals with the improved version of a cognitive process not only have more babies, are more successful in biological reproduction, but also it depends on the extent to which they attract more students, more children who learn from them their improved variant of the cognitive process. That's how distinctively human cognitive mechanisms get to do their jobs well at the population level through cultural selection. At the individual level, each of us is born not with a program for the development of a distinctively human cognitive mechanism, but with quantitatively expanded cognitive processes relative to other animals. And these build through social interaction in the course of development the distinctively human mechanisms, the cognitive gadgets. So to put it another way, I'm suggesting that distinctively human cognitive mechanisms are a bit like simple pieces of technology, traps, spinning wheels, canoes. If you think about the design of a canoe, why a canoe does its job well, it's not due to genetic evolution. It's probably also not due to design by individuals or groups who had the purpose of making effective vessels which would float and would move through water, possibly with knowledge of hydrodynamics. Canoes were not designed in that way. Rather, they became good at doing their jobs through cultural selection. That is, people made various different boats. The boats that were, as it happened, good at doing their jobs were still afloat, were still available when people wanted to make more boats. So the better variants got copied more than the not so good variants. So I'm suggesting distinctively human cognitive mechanisms have evolved in the same way as canoes by cultural selection. Now, let's make that more concrete by using the example of imitation. The term imitation in cognitive science is used more specifically than in everyday life to refer to learning by observation of the actions of others, how to move the parts of one's body relative to one another. So this little boy is imitating the men, not by virtue of the fact that he's moving in the same direction in space, but rather because the parts of his body, his arms and his torso, are configured relative to one another in the same way as the parts of the men's bodies. Now, imitation is of interest to those interested in human origins because it's thought that imitation allowed our ancestors, and still us alive today, to learn to make and use tools, and also that it allows us to acquire the gestures and ritual movements, many of them involving dance, which promote social bonding and thereby promote cooperation. So imitation is important in human evolution and in contemporary life. Now here is the cognitive gadget account of imitation, of what imitation involves at the cognitive level. This gadget account suggests that we are born with a capacity for perceptual sequence learning and a capacity for motor sequence learning. Motor sequence learning is the process which enables us to encode a series of perceived events. So it might be the order in which cars pass my window, or it might be the sequence of events that leads up to an animal that I'm hunting emerging into the open. Motor sequence learning enables us to encode a sequence of body movements, the sequence of body movements involved in riding a bike or in throwing a spear. This is essentially motor learning. Now, lots of other animals are capable of perceptual sequence learning and of motor sequence learning. We may be a little better at one or the other than some other animals, but it's a quantitative difference. What's special about humans is that in the course of childhood development, perceptual sequence learning and motor sequence learning become geared together to create a new system which is capable of imitation, a new system in which perceptual sequence learning can drive motor sequence learning. They're geared together by what we call matching vertical associations. That is bidirectional excitatory links, each connecting a sensory representation of an action, say bowing. This might be a representation of what it looks like when you watch somebody else bowing, and a motor representation of the same action, what it feels like to bow. Now, crucially, these matching vertical associations, according to the gadget theory, are learned, and they are learned through basic mechanisms present in a very wide range of animals through associative learning mechanisms. So at birth, there is no special connection between, say, a sensory representation of grasping, what it looks like to grasp, and a motor representation of grasping, involved in performing the action of grasping. At birth, no special connection. But soon the infant begins to have experiences which result in correlated activation of these two representations. So when the baby watches herself grasping, the motor representation is active, involved in producing the movement. And because she's watching, while she's producing the movement, she gets to see that action. The sensory representation is also activated. This correlated activation, according to associative learning theory, studied for more than a century through conditioning experiments with animals, this correlated activation will result in the formation of a bidirectional excitatory link between these two representations, such that in future, whenever this one is activated, it increases the probability of this one being activated, and vice versa. Now, I've started with the example of self-observation, but in fact, many of these matching vertical associations, which make imitation possible, will be established through much more social experience in the course of childhood. For example, through the performance of synchronous activities such as drills. When an individual takes part in a drill like this, they are performing the action while seeing it done by others. You get that correlated activation, which will establish the bidirectional excitatory link. Similarly, when a child acts while looking in a mirror, a cultural artifact, they will get this correlated experience of seeing and doing. And crucially, when an infant is imitated by an adult, that experience will enable the infant to forge a matching vertical association for the action imitated. So in that case, the infant is inheriting directly through social interaction the capacity to imitate from the parent. So you might say the gadget theory is neat enough, but what about the evidence? There's now a pretty substantial body of evidence, much of it summarized in these two articles, and much of it coming from training experiments which show that imitation behavior and the activity of mirror neurons, which is one neurological substrate for imitation, can be changed radically by giving people novel sensory motor experience. To give you a flavor of those studies, I'll mention a couple of recent ones. They're not the most dramatic, but they are the most, two of the most recent. In this study, which was done in Caroline Katmer's lab, we first demonstrated an automatic imitation effect for object-directed actions. So participants were asked to, for example, perform a precision grip, to lift a block using a precision grip on a number of occasions, and to do this in a speeded way. Sometimes the go signal telling them do it now was the sight of a precision grip, this image. Sometimes the go signal was an imitatively incompatible action. It was this image, a power grip, that told them, go, perform your precision grip. Now, both when the executed and observed action was spatially compatible and when the two actions were spatially incompatible, the precision grip, for example, was performed faster when the go signal was a precision grip, when the action was imitative, than when the go signal was a power grip, when the action was not imitative. So that's the automatic imitation effect. Now, importantly, people were then given training in which whenever they saw a power grip, they performed a precision grip. And whenever they saw a precision grip, they performed a power grip. Now, this counter mirror experience, just 400 trials of that experience, abolished the automatic imitation effect. This is what we predicted on the assumption that the counter mirror experience, see precision while do power, and vice versa, would establish a non-matching vertical association that would overlay the matching vertical association established in the course of normal development, and thereby abolish the automatic imitation effect. So that was an experiment with adults. The other example I want to show you, which was led by Corinna de Klerk, was with 4-month-old infants. And what Corinna did was to bring the infants into the lab and first record a free play session in which they were spontaneously playing with their mothers. And in that session, she recorded how often the mother imitated the facial expressions of the infant. Then she recorded from the infant's facial and hand muscles while the infant was watching an adult perform facial or hand movements. And as predicted by the gadget theory of imitation, she found a difference between the infants whose mothers imitated them a lot versus the infants whose mothers imitated them rarely. The infants with high maternal imitation showed lots of activity in their facial muscles, eyebrow and mouth, when they were watching facial movements. So there was this sub-threshold automatic imitation in the infants who had been imitated a lot by their mothers, but that effect was absent in the infants that had been imitated rarely by their mothers. Again, consistent with the gadget theory of imitation. But what about neonatal imitation? If newborn humans are capable of imitating a range of gestures, as many people have believed since classic studies were published in the 1970s by Meltzoff and Moore, then surely that shows that imitation isn't a cognitive gadget. It must be a cognitive instinct. We must genetically inherit a program that enables us to imitate body movements. Now, the neonatal imitation data have always been contentious ever since the late 1970s when they were the first were published, and they've been difficult to replicate. But I think in the last few years, Virginia Slaughter's lab in Brisbane has done work which I think resolves this issue. In 2016, they published a study in which they had tested more than 100 infants for imitation of 9 gestures and tested them longitudinally at 1, 3, 6, and 9 weeks postpartum. And they used the gold standard method, which was introduced by Meltzoff and Moore in the 1970s, and failed to find reliable evidence of imitation for any of the 9 gestures tested. So there was a trend in the case of tongue protrusion. The red line shows the frequency with which the infants put out their tongues after seeing tongue protrusion, compared with the frequency of tongue protrusion after seeing the other 8 gestures. There was a trend, it wasn't reliable. And in the other cases, there wasn't even a trend. Now, previous failures to find neonatal imitation have been explained with reference to a range of methodological factors. So what Slaughter's lab has done is a meta-analysis of 336 effect sizes, a massive meta-analysis of previous research on neonatal imitation to look for an impact of those methodological factors which are supposed to explain why neonatal imitation is sometimes found and sometimes not. Their study is currently in press in Perspectives on Psychological Science. It looked for a modulating effect of 13 methodological variables, which have been cited as important, and found no effect of any of those 13 methodological factors. However, what it did find was an effect of researcher affiliation on effect size. So the positive effects are coming from just 5 laboratories, and across the whole data set, 336 effect sizes, there is a relationship between standard error and effect size, which suggests publication bias. It suggests that additional studies have been run, they have not provided evidence of neonatal imitation, and therefore they have not been published. So after a long period of controversy, I think it's now clear that neonatal imitation is not a reliable phenomenon. Okay, so I've told you more about what I mean by cognitive gadgets, distinctively human cognitive mechanisms shaped at the population level by cultural selection rather than genetic selection, and at the individual level developed through social interaction, driven by mechanisms, in the case of imitation, associative learning, that we have in common with a wide range of other animals. Now let's turn to the implications of the gadget view for people in cognitive science who are interested in origins, in the development and evolution of cognition. What would a cultural evolutionary psychology, in contrast with a standard evolutionary psychology, look like? Well, first of all, it would not infer innateness from adaptiveness, from early development, or from neural localization. A cognitive mechanism can do its job well, it can appear early in development, and it can show neural localization without being a cognitive instinct. A cognitive mechanism can be adaptive by virtue of cultural selection. It can appear early in development due to early social interactions, such as the ones that came up in connection with Corinna de Klerk's study, where mothers were imitating their infants and thereby promoting imitation by their infants. And a cognitive mechanism can show neural localization or neural specialization when it is recycled from old parts. Second, a cultural evolutionary psychology would be very interested in old parts. It would not treat cognitive mechanisms like imitation or mind reading theory of mind as black boxes delivered by the genes. It would be constantly asking what they're made of and how they work and how they came to work that way. Specifically, when it comes to the question of how they came to work that way, a cultural evolutionary psychology looks for wealth of the stimulus. So this is a contrast with Chomsky's poverty of the stimulus. It would look for evidence that there is sufficient information in the developmental environment to support the development of the cognitive mechanism to mature form. Yet more specifically, it would look for evidence of cultural learning. So this term, cultural learning, is now used quite often in a loose way as a synonym for social learning. That is, any kind of learning in which another agent assists in any way, or learning where other agents are what is learned about. Now, people can use terms in any way that they want to, but I do think it's important to recognize that there is a significant subset of social learning, what I'm calling cultural learning, in which one agent doesn't just learn about other agents, they learn from other agents. So what I learn from you doesn't only depend on what you do or how you appear, it depends on what you know. And that kind of social learning, cultural learning, constitutes an inheritance system analogous to genetic inheritance. So what are the signs of cultural learning? They include cultural variation, not just in what is believed or what is known, but in how cognitive mechanisms operate. And cultural learning is also evident in training and expertise effects. So to make all of that more concrete, let's look at metacognition. Metacognition, in the broad sense, the capacity to monitor, represent, control behavior control processes, cognitive processes. A simple form of metacognition, what one might call implicit metacognition, is present in a wide range of animals. They can make use of error signals arising from their cognitive processes. But explicit, a conscious explicit form of metacognition may be distinctively human. Explicitly metacognitive representations depend on working memory, they are conscious, and they are typically verbally reportable. They allow us to say, I'm sure, or I'm not so sure. They detect error, they detect these explicit metacognitive processes, detect error, they detect attentional lapses. By that means, they allow effective deployment of executive functions and cognitive offloading. And the payoff is improvements in study efficiency, for example, rereading a text when you realize that you didn't take much in, better group decisions in juries, in sports teams, and so on. And a nugget I came across recently, it would appear that effective explicit metacognition enables us to avoid contracting radical political beliefs. A recent article published in Trends in Cognitive Sciences, together with some metacognition specialists, Dan Bang, Nick Shea, Chris Frith, and Steve Fleming, I argued that the unconscious processes that control behavior, here modeled simply in terms of processing of sensory input, a decision-making system, and an effector-output system, that these unconscious processes send to consciousness a variety of different experiences. So, for example, there are perceptual experiences that come from the analysis of sensory input. There are experiences of acting that come from the effector-output system. And these processes give rise to metacognitive experiences, such as the experience of fluency or the experience of ease of processing. But, we argue, the developing child has to learn to distinguish these kinds of experiences from one another and to learn what they mean. The child has to learn to discriminate and to interpret. Crucially, we argue that that learning is cultural learning, that it occurs through social interaction. Now, there is already evidence supporting this account of metacognition as a cognitive gadget. It comes from, for example, expertise studies. Fox and colleagues showed recently that people who practice mindfulness meditation, a set of practices that are thousands of years old, broadly Buddhist, show better metacognitive sensitivity in a tactile discrimination task than people who don't practice mindfulness meditation, and that the degree of metacognitive sensitivity varies with the number of hours of meditation which have been practiced, between 1 and 15,000 hours. Another quite neat example is a study from 2006 by Brinol and colleagues, in which they asked student participants to read a text about new examination policy. And they induced metacognitive feelings of ease of processing or dis-ease, poor fluency, by asking them to read it either in black text on a white background or in yellow print on a pink background, which is much harder to read. But the interesting manipulation was that half of the participants in each of these two groups was given instructions at the beginning of the experiment, which either led them to interpret ease of processing as a bad sign or ease of processing as a good sign. So they were either told that, people sometimes experience, a great feeling of ease when they're reading. This implies that they're processing the material in a very shallow, unintelligent way. Or they read a comparable text which left the normal assumption for most of us intact, which is that fluency of processing should inspire confidence. It indicates that you've understood, that you're doing well. And they found, when they asked people to give their attitudes towards the new examination policy, and to rate their confidence in those attitudes, that the people who've been left with the usual assumption expressed higher confidence in the ease of processing than the difficulty of processing condition, whereas those who had been instructed had had the opportunity to learn culturally that ease of processing means you're not thinking hard enough. Those people expressed more confidence in the low ease than in the high ease condition. So there is already evidence supporting the gadget theory of explicit metacognition, but compared with many other cognitive gadgets, imitation, mind reading, and so on, there's much more to be done. So let's think about what needs to be done. Well, first of all, we need to look for evidence of cultural variation in metacognitive sensitivity. So there's already plenty of evidence that people from some cultures, for example, United States and Australia, express more confidence in general than people from, say, Taiwan, Hong Kong, or Japan. But that's metacognitive bias. As far as we could tell, there is currently no evidence, no studies of cultural variation in metacognitive sensitivity. And a cultural evolutionary psychology would not only look for such variation, but try to link it with differences between cultures in the way in which parents, for example, speak to their children about confidence and the kinds of games they play with infants and children. Similarly, we wouldn't only expect that sort of relationship in variation across cultures, but also in individual differences within cultures. We'd expect them to be correlated with social abilities and experience. So just as Corinna de Klerk found that how much infants were imitated by their mothers influenced how much imitation the infants themselves performed, we would expect children whose parents talk to them a lot about confidence and in a subtle way, and play games with them like peekaboo, to be better, to have higher metacognitive sensitivity than children who are talked to less about confidence and who are played with less with those metacognitive sensitivity building games. I've mentioned games and conversation as sources of cultural learning of metacognitive sensitivity. They may have different roles. A plausible theory is that games promote discrimination. They help children to distinguish emotional feelings and perceptual feelings from metacognitive feelings, whereas talk about confidence influences interpretation, that it helps children to learn about the significance of different metacognitive feelings. And finally, on this to-do list, we have, are people with high metacognitive sensitivity better metacognition teachers than those with low metacognitive sensitivity? Now, this is an important one for a cultural evolutionary psychology because, as I said earlier, in cultural learning, what I learn from you depends not just on how you appear, not just on how you behave, but on what you know. So this correlation would be indicative of a cultural inheritance system analogous to genetic inheritance, a basis for cultural selection. So, using the example of imitation, I've explained what I mean by cognitive gadgets, and using the example of metacognition, I've given some indication of what this view implies for cognitive science, the kinds of questions that cognitive scientists interested in the origins of cognition in development and evolution might ask what a cultural evolutionary psychology looks like. And I hope some of you will want to give it a try. Thank you.